Good morning, students. Today we will study conformations. Conformation of cyclohexane. So cyclohexane is a cyclic compound, but it is having single bond. C6H12. Its formula is C6H12. So we will see conformation of cyclohexane. First, structure of cyclohexane. Formula is C6H12. So it will look in this way, and six carbons and 12 hydrogens. On each carbon there are 2 hydrogens. So there are 12 carbons, 12 hydrogens are there and 6 carbons are there. Formula is C6H12. This is the structure of cyclohexane. Now conformation of cyclohexane. Cyclohexane exists in two non-planar stainless forms. They are board form and chair form. So while saying the conformation of cyclohexane, we will see that it exists in two forms, board form and chair form. This is the chair form of cyclohexane. This is the structure of cyclohexane. This is the chair conformation of chair form of cyclohexane. Board conformation of cyclohexane. So here also 6 carbons are there and 12 hydrogens are there. On each carbon there are 2 hydrogens. On each carbon there are 2 hydrogens, and we will name from here 1, 2, and now down 3, 4, 5 and 6. So 6 carbons and 12 hydrogens are there. On each carbon there are 2 hydrogens. So this is the board form of cyclohexane, and this is the chair form of cyclohexane. On each carbon there are 2 hydrogens. One is axial hydrogen, one is equatorial hydrogen. So here both are having, so one is equatorial and one is axial. So on each carbon there are one axial and one equatorial hydrogen, and this both are having the formula C6H12. Means cyclohexane can exist in board form, in the board shape also, and in those chair form. Means it is existing in different form. That is known as conformation. So planar structure of cyclohexane, we are seeing C6H12 in hexagonal shape. We are having 6 carbons and 12 hydrogens, and board form of cyclohexane. This is twist board form of one more form of cyclohexane, twist board form, and this is the chair conformation of cyclohexane. On each carbon we are seeing there are 2 hydrogen, one axial hydrogen and one equatorial hydrogen. These are the 4 forms of, in the 4 way we can write the structure of cyclohexane. Board form. In the board form, carbon atom 2, 3, 5, 6 are in the same plane, and carbon atom are above the plane. So in this is the board form. 2, 3, 4, 6. 2, 3, 5 and 6 are in the same plane, and carbon atom are above the plane. So they are in the same plane, and these are above the plane. Chair form. In the chair form, carbon atoms 2, 3, 5, 6 are in the same plane, but carbon 1 is above the plane while carbon 4 is below the plane. So carbon 1 is above the plane and carbon 4 is below the plane. Carbon 1 and 4. This carbon 1 is above the plane. Means this is a plane above the plane, and 4 carbon is below the plane. The bond angle is 109 degrees 28 minutes. So the bond angle HCH bond angle is 109 degrees 28 minutes. So this is the bond angle of tetrahedral. So it is having tetrahedral bond angle. The chair form is more stable conformation than the board form of cyclohexane. Chair form is more stable than board form of cyclohexane. The chair form and board form are interconvertible. Chair form can be converted into a board form, and board form can be converted into chair form. So the chair form is more stable conformation than the board form, because in the board form these 2 hydrogens are coming closer to together, and so there is steric hindrance in the molecule. So board form is less stable than chair form. Axial and equatorial bond. In cyclohexane molecule there are 2 kinds of C-H bond. The 6 C-H bonds which are in the plane of the ring and makes an angle of 109 degree 28 minutes with the axis of symmetry are called equatorial bond and denoted by E. So there are 6 C-H bond you are seeing. C, this is the first one, 2, 3, and 6. H, it is written in the near the hydrogen, it is written E, that is equatorial bond, and then near if it is A, that is axial bond. The 6 C dash H, which are parallel to the axis. So the axial bonds are parallel to the axis, and they are this equatorial are with the axis of symmetry. Meaning the axis means it is vertical you are finding, then it is equatorial bond, and if you are to the center of axis, if they are parallel, then it is axial bonds. So in each carbon there is one axial hydrogen and one equatorial hydrogen. So there are 6 C-H equatorial bond and 6 C-H axial bond. So axial and equatorial bonds in the molecule. How many? 6 C-H axial bond, 6 C-H equatorial bonds in cyclohexane molecule. This is a 4-mark question, and it is asked explain the conformation of cyclohexane. So you have to write all these points. Thank you.